as said, my name's Amanda Schadeberg. I work at the Wageningen University in the Netherlands. And rather than present empirical work that I've done myself, I thought today I would present some of the theories and concepts that have been guiding my PhD research so far. And before I begin, I'd like to also just thank all of the people who've been helping me along the way. So there's two brilliant early career science networks that I've mentioned, Oyster and the MSEAS Strategic Initiative for the Integration of Early Career Scientists. They've both been instrumental in giving me energy during this pandemic year, as well as the MSEAS project, which funds my PhD research, and many, many inspiring colleagues at the university. So I'll kick off with my perspective on uncertainty and complexity, which are two key words in my PhD work. So beginning this talk, I thought, here's me 2 years into my PhD, still in my academic baby shoes, really, and I'm at the beginning of my scientific career. And I decided to think a little bit about what I see the world looking like when I get to the end of my academic career. So I thought, okay, this is going to be the Amanda of the future. And then I started thinking a bit harder about this. I realized that with projected retirement ages, there's increasing lifespans, skewed population pyramids. I'm probably going to look more like this by the time I'm actually allowed to retire. I'll be 70 something. But what worlds does this future Amanda live in? So hopefully she lives in a world where 2050 is a distant memory. We've achieved net zero and the climate crisis is long behind us. The world's population is predicted to have leveled off at about 10 billion by the time I retire. By the time I retire, everyone alive will be a true digital native, and we'll have the digital system so well integrated into our society, we'll be living in a paradise of convenience and information. And cryptocurrencies may have toppled our old financial systems, democratizing capital, superseding governments, and perhaps improving financial equality for all. So for us as humans, we might end up looking a little bit like the characters out of Pixar's Wall-E, comfortable, well-nourished, and very digitally engaged. But there are alternative futures that I could find myself in. I could find myself in a world that looks a little bit more like the movie Mad Max, where we don't reach our climate goals, the climate collapses and we have desertification, which leads to a collapse in the population because there aren't enough resources to sustain us. Who is left fights over the technology that's left behind and weaponizes it against one another. And we live in a world of extreme haves and have-nots. Now, hopefully that's not the future that I will land in, but where we go depends on many complex choices. So I wanted to also look a little bit at the history of the future as another illustrative example of what we think of when we think of the future. So now going back in time to the year 1900, a chocolate brand decided to advertise their chocolates with a campaign in which they visualized what they expected the year 2000 to be. So this was personal aviation in the year 2000. They didn't really get the fashion right, and I don't think they got the aerodynamics right, but this was quite a romantic view of what personal mobilities would look like. And here's one that I think is a little bit closer to the truth. So this is a prediction of North Pole tourism in the year 2000. And that's something that has actually come to pass. We do have tourists visiting the North Pole. And though they're not arriving by helium balloons, they're coming by icebreakers. And I think there's a lot less wildlife and indigenous people than these chocolate makers envisioned. But it's not just chocolate makers that are in the business of predicting the future. Scientists as well can weigh in on the future of the Arctic. And by the time we reach my retirement, which is the line that I've added there to this figure that I've taken from a paper, the Arctic sea surface temperature will be somewhere around 2 degrees, which means that these holiday makers are probably going to look a little bit more like this. So what's happening in marine science and in science in general is that we're increasingly looking more and more towards the future. So I said I wasn't going to present empirical work, but maybe this counts. I just went onto the Web of Science and I extracted papers with the title, with the words marine and future in the title. And I've just highlighted the last 3 decades. So in the year that I was born, 1991, there were 0 papers published about marine futures. By this year, we get to 56. So we see quite a steep trend. And some of you may be saying, okay, Amanda, but scientific output is increasing. So I did my due diligence and I also calculated this as a rate. So I took all of the marine publications with marine in the title, and then I took ones that also contain the word future. And we see that in 2021, almost 1% of publications that came out in the Web of Science database were concerned in one way or another with the future. And just to illustrate my point one more time about the absurdity of our relationship with the future and how the future is this fluid thing that exists in the present already, we have scientists publishing about the future in the journal Futures. So it's starting to get really, really complicated. But the future of the ocean and the future of the marine world is also a concern in the public domain as well. So these are just two images that I pulled from public-facing blogs. The first one projects the ratio of plastic to fish for the year 2050 with quite a dire outcome. And the second image does a similar thing. So they take a trend in global fisheries data and they extrapolate that until the year 2050 to show that 100% of species will have collapsed by then. But we in the room know that making these predictions, it's not always so simple as following a trend. Recent work which has shown the concept of blue acceleration shows us that we cannot expect that trends will continue at the same pace. In fact, humanity is expanding into the ocean at a really rapidly accelerating pace, one that which policy is unlikely to be able to keep up with. And as a result, a lot of what we present, and this is a graph taken from that same paper which showed the Arctic sea surface temperature, often scientists are presenting their results in terms of potential scenarios and with large uncertainty ranges. And this is quite sensible because in times of acceleration and dynamic complexity, we understand that the past is no longer a reliable predictor of the future. And this is quite a dramatic change in the history of human psychology, when we could assume that this tomorrow would look a lot like today, or at least this summer would look a lot like last summer. So what can we do in light of this? So I see marine science heading in a direction of anticipation and foresight, and this is instead of practices of prediction and forecast. So just to model this for you, we have our linear conception of time, and I acknowledge that this is there are many non-Western schools of thought that have circular conceptions of time, but the majority of scientific work takes this linear trajectory where the future is somewhere out there. And for a lot of conceptions, the future is one singular place. But some time ago, we became comfortable with the idea that there are multiple possible futures branching out ahead of us. There are plural options, and it's up to us which one we choose and where we end up. So what foresighting or anticipating does is explore each of these futures or a selection of these possible futures. We might select one, zoom in, and that will prompt the question of what does this mean for today? So by selecting a particular future, we can set it as a target and we can start deciding what actions we might need to take today. And we can set ourselves some milestones or some goals to work towards. We can even set ourselves some red flags to check that we're heading in the right direction. So this whole process that I've just outlined is quite a political one. There's a lot of decisions that are being made, and the ideas that we have about the future, as I've just shown, will shape the actions that we take in the present. And we see this in the marine space, but we also see it with climate change, and we've even seen it with the coronavirus as well. And this matters because how we anticipate a resource and how we interact, or how we anticipate our interactions with the environment around us, can actually come to construct our environment as a resource. And once that construction process is set in motion, these resources can then be claimed by social and political processes, and individuals or countries or companies can lay claim to these parts of the environment. And thus, I argue that anticipation, and others have argued as well, that anticipation can be an act of colonizing the future. So I mean this in two senses. The first is that we colonize the future in the sense that we send our current selves forward. We take our priorities and our values of today, and we pass them forward into the future when we're formulating what decisions we might need to make today to reach that future. And the second meaning of colonizing the future is that the power to anticipate this future has not always been evenly distributed. And so this paper is almost as old as I am. And the author argues that both wittingly and unwittingly an elite, and they go on to define what that elite is, but for this audience, I don't think I have to, decides what is and what is not important in decision-making about the future. So you may be saying at this point, but we're scientists, not politicians, and that's true. But the models, scenarios, problem framing, all of these things that we use in our environmental issue-driven assessments are laden with sometimes hidden values. And these hidden values become important for governance through this concept of de facto governance. So colleagues of mine at Wageningen University have argued that by working on seemingly apolitical questions, scientists can actually exercise de facto governance, by which they mean that in settings where scientists are answering questions in anticipation of particular challenges, the assessments that they make can actually demarcate or delineate topics in a way that produces frames that ultimately shift the governance debate. And one really easy example of this is being given a question, scientists very quickly shift gears from thinking of what, if, and whether, because that would be a normative question, and that's not what scientists do, to how, when, and who. But just in doing so, we may set the wheels in motion for exploitation or conservation of a particular resource. And I just wanted to think about how can we move forwards. And I read this brilliant book recently by Naomi Oreskes, and she's argued in it that in diversity there is epistemic strength. And we see this argument come up elsewhere as well. The post-normal science literature says this stuff as well. But what she means by this is that science as an enterprise is shaped by practices of criticism and correction. And these practices are peer review, conferences such as these, where we share our ideas and question them with one another. But these practices and these conventions are only as good as the community is diverse. So only a short tour of the history of science will show the dangers of a lack of diversity in the scientific endeavor. So phrenology, scientific racism, sexism has led to many scientific claims which have later been shown to be deeply prejudiced and deeply politically motivated. But we're working to fix that. And this is just one example from the MSEAS community, but there are millions of them emerging, of ways that we can consider participatory research methods where we can create this diversity in our scientific work, where we can bring in different knowledge systems, different perspectives, different experiences into the scientific enterprise. So I couldn't have the platform and not speak just briefly about my own work. So now that you understand a little bit the conceptual framework that I'm dealing with, the case that I've taken is the mesopelagic zone, and that's through this Horizon 2020 project MESO. And the mesopelagic zone is a really fantastic case for this work. It's really big, it's really expensive to observe. It's a very, very complicated ecosystem of which there's a lot of uncertainty. And what's interesting about this ecosystem, marine ecosystem, compared to many others, for example, the small scale fisheries that we just heard about, is that scientists are truly the gatekeepers here. If I'm a scientist, but if I'm down in the mesopelagic zone interacting with the fish, it's generally going to be bad news for me because I'm going to be 200 meters below the water. So there's a very small club of people who can actually interact with this ecosystem and shape our understanding of it. And it's recently been discovered and promoted as a potential resource for potentially sustainable exploitation. So this brings me to this juicy sort of question where I see that there are decisions that are being made in a highly anticipatory way. So they're taken under conditions of extreme uncertainty. Policymakers want to know what to do next, even though the science hasn't come to any solid conclusions just yet. And there are also conflicting normative perspectives about the potential demands, risks, and harms. And we see those normative perspectives in members of the public, but also amongst the scientific community as well. And just to give an example of this process of demarcation and delineation, which is a bit jargony from the previous slide, but this de facto governance is already in action in the sense that the mesopelagic zone has been defined as the part of the ocean from 200 meters to 1,000 meters deep by scientists. And that is now bleeding out into the political realm as well, where this delineation of what is the mesopelagic zone is starting to come alive in the political sphere as well. So the work's still ongoing. Please watch this space. Please check in with me in a few years' time when I'm presenting my dissertation to see what I come up with. And I wanted to draw some conclusions based on what I've just presented you. And I went to the MSEAS 2020 program to look at the keywords. And I'd written 3 conclusions, and I was able to actually find keywords from the MSEAS program that link to each of them. So that's what I've done there in the orange. And so the first of my conclusions is that as a community, we should really be getting comfortable with complex uncertainties and with multiple futures. So we should be speaking about marine futures always in the plural sense, in the sense that we have scientific scenarios that we have to explore and do our due diligence on, but also that there are different political and social realities and futures that are possible. The second call is that we should reconfigure our relationship with ourselves. So we know in this community that the human dimension is crucial, but we scientists are human as well. So how can we place ourselves and our behavior in the systems that we study? This is advanced work. It's really exciting stuff, but it requires a lot of reflexivity and transparency. But I think the MSEAS community, looking at the keywords that are there from the planned sessions, the MSEAS community is very well prepared to do this kind of work. And finally, thinking of myself, my future career, who I'm shaping up to be as a scientist, I really think we should see diversity and interdisciplinarity as a strength. So our world is becoming increasingly specialized, not just in science, but everywhere. And we're encouraged more and more to specialize and find our niche. But the problems that we're facing are becoming increasingly integrated, globalized, and embedded in complex systems of economics and society and global politics. So we really need this diversity and interdisciplinarity to prepare us for that future. So I'm just going to flash the sources here for the sake of the recording. And I'll close by saying thank you very much for your attention. I've placed my email address there if you'd like to get in touch. Otherwise, I'm happy to hear from you in the discussion, as well as 2 QR codes that link to the early career science networks that I've been involved with. So if there are other early career scientists in the audience who'd like to get involved, please reach out and chat, because it's been a really wonderful experience. And one last thanks to all the people listed there and the many, many more who I couldn't. And thanks once more to MSEAS for giving me this opportunity.